Your body has fought cancer thousands of times without you knowing, and one day, it might lose that silent battle. Imagine waking up tomorrow and discovering that a war had been raging inside your body for years. A war so intense that entire populations of cells had lived and died, cities had risen and collapsed, and battles had been fought without you ever noticing. No alarms, no pain, no warning. Just silent conflict unfolding in the dark, every single day. The first time I truly grasped this idea, it unsettled me in a way few scientific facts ever had. I had always thought of the body as stable, predictable, a system quietly doing its job. But biology doesn't work like that. Life is not static, it is restless, constantly repairing, constantly correcting mistakes, and sometimes, those mistakes refuse to be corrected. Cancer, as I came to understand, does not begin with a dramatic event. There is no sudden explosion, no instant transformation. It begins quietly, almost invisibly, with a single cell making a single bad decision, or more accurately, losing the ability to make good ones. Under normal circumstances, our cells are remarkably disciplined. They follow instructions written into their DNA. They divide only when necessary. And when they become damaged beyond repair, they perform an extraordinary act of cooperation. They shut themselves down. They die so the rest of the body can live. But once in a while, something goes wrong. A cell accumulates damage it cannot fix. The internal signals that tell it to stop dividing fall silent. The self-destruct mechanism fails, and instead of stepping aside, that cell continues forward, copying itself again and again, carrying its mistakes into the future. At first, nothing seems unusual. You feel fine. You go to work. You laugh with friends. Life moves on exactly as before. Yet deep inside, that one cell becomes two, two become dozens, dozens become thousands. And here's the part that still amazes me, and honestly, still frightens me a little. Most of these abnormal cells are flawed, weak, doomed to fail. But a few will survive, a few will adapt, a few will discover ways to grow faster, consume more resources, and ignore the rules that keep the rest of the body in balance. This is how the story begins, not with cancer, not with disease, but with a quiet rebellion, a tiny cluster of cells forming in the shadows, too small to detect, too small to feel, and for a while, too small to matter, until one day, it does. And just when that quiet rebellion begins to take shape, something remarkable happens. Your body notices. What struck me the most when I first learned this was not how dangerous the tumor could become, but how quickly the body responds once the balance is disturbed. Cells around the growing cluster begin to suffer. They struggle to get enough oxygen, nutrients become scarce. Some cells die in ways they shouldn't, leaving behind chemical traces, signals that something is wrong. It's almost like smoke drifting from a hidden fire. You may not see the flames yet, but the system designed to protect you already senses the danger. This is when the immune system moves, not dramatically, not recklessly, but with precision. Macrophages arrive first, quietly sweeping through the area, consuming debris and damaged cells. They are not just cleaners, they are observers, gathering information, assessing whether this disturbance is temporary or something more serious. Natural killer cells follow close behind, scanning every cell they encounter, looking for subtle changes, small differences that reveal a cell no longer belongs. I remember feeling a deep sense of respect when I realized how vigilant this system is. Your immune system does not wait for symptoms. It does not wait for permission. It acts early, often before you even realize there was ever a threat. But what truly fascinated me was the coordination that follows. Dendritic cells collect fragments from the abnormal cells, tiny molecular clues, and carry them to the immune system's command centers. There, they present the evidence to specialized T cells, the most disciplined defenders in the body. These cells don't attack blindly, they study their target, recognize what makes it dangerous, and respond with astonishing accuracy. Soon, the response intensifies, blood supply to the abnormal tissue is restricted. Growth slows, cells that once multiplied rapidly begin to weaken. One by one, they disappear, and healthy tissue starts to recover. In many cases, this is where the story ends, a threat detected, confronted, and erased before it ever becomes visible. But biology has a way of humbling our confidence, because even in a decisive victory, survival sometimes favors the one cell that refuses to die. And that single survivor, the one cell that slips through the cracks, is where the story takes a turn I never expected when I first began studying this process. At first, it seems unfair. The immune system did everything right. It detected the threat early, mobilized its defenses, and cleared the battlefield with astonishing efficiency. Yet somehow, one cell remains, quiet, invisible, waiting. The more I learned about biology, the more I realized this isn't a failure of the body. It's the natural consequence of something much deeper, evolution. Inside that tiny survivor, change never stops. Each time a cell divides, small variations appear. Most of those changes are meaningless. Some weaken the cell. But occasionally, one gives it an advantage, the ability to grow a little faster, to survive with less oxygen, or to hide more effectively from the immune system's surveillance. And when survival becomes a competition, even the smallest advantage can shape the future. What unsettled me the most was understanding that the immune system itself plays a role in this transformation. By eliminating the weaker cells, it unintentionally leaves behind the strongest ones. It's a brutal kind of training process, one that refines the survivors again and again. The next generation of cells is no longer the same as the first. It is tougher, more adaptable, more determined to persist. This cycle can repeat quietly for years, growth followed by attack, destruction followed by survival, each round making the remaining cells harder to defeat. Over time, those survivors begin to behave differently. They stop responding to signals that normally control cell division. They find ways to secure resources more efficiently. They adapt to conditions that would kill ordinary cells. And then, eventually, a change appears that shifts the balance completely. The surviving cells discover how to interfere with the immune system itself, not by hiding, but by manipulating the very signals designed to keep the body safe. That is the moment when a manageable threat becomes something far more dangerous, and when a simple cluster of abnormal cells crosses an invisible line and becomes true cancer. And once a cancer cell learns how to manipulate the immune system, the battle changes in a way that is both fascinating and deeply unsettling. What I didn't realize at first, and what took me a long time to truly appreciate, is that the immune system is powerful precisely because it knows when to stop. It carries built-in restraints, biological safeguards that prevent it from attacking the body endlessly. Without those restraints, the very system designed to protect us could become destructive. Inflammation would spiral out of control, healthy tissues would suffer. So nature installed an off switch, a signal that tells immune cells, "Stand down, the threat is over." But cancer, in its relentless drive to survive, finds a way to press that switch. Instead of hiding from immune cells, the tumor begins sending misleading signals, chemical messages that mimic normal tissue. To the immune system, everything suddenly appears calm, even when danger is growing. The response weakens, attacks slow down, and in that silence, the cancer gains time to reorganize, to strengthen, to expand. This is where the story becomes more complicated than I ever expected. The tumor doesn't just grow larger, it begins to reshape its environment. Blood vessels form around it, feeding it steadily. Surrounding cells are recruited and altered. The space around the tumor becomes a kind of protective territory, a biological zone where immune defenses struggle to function. Scientists call this the tumor microenvironment, but to me it feels more like a borderland, guarded and difficult to cross. As this protective barrier forms, the cancer gains confidence. Cells break away from the original mass and travel through the bloodstream, drifting like seeds carried by the wind. They settle in distant tissues and begin building new colonies, repeating the same pattern of survival and expansion. This is the moment when cancer becomes truly dangerous, not because it suddenly appears, but because it escapes control. And standing back, looking at this process, I can't help but feel a strange mix of respect and concern, because cancer is not acting out of malice. It is simply following the oldest rule in biology: survive, adapt, and keep going, even when the cost is everything. And yet, even in the face of something as relentless as cancer, what gives me the most hope is realizing that this battle is no longer being fought by the body alone. For decades, medicine tried to defeat cancer by attacking it directly. Surgeons removed tumors when they could reach them. Radiation damaged cancer cells from the outside. Chemotherapy targeted fast-growing tissue in hopes of stopping the spread. These approaches saved countless lives, and they still do. But the more I read, the more I began to see their limitations. Cancer is not a single enemy with a single weakness. It is a moving target, constantly changing, constantly adapting. Fighting it head-on is necessary, but sometimes it isn't enough. That realization led scientists to ask a different question, one that I find both simple and revolutionary. What if the most powerful weapon against cancer is already inside us? This is the idea behind immunotherapy, and the first time I understood it, I remember feeling a genuine shift in perspective. Instead of trying to overwhelm cancer with external force, doctors are learning how to strengthen the body's own defenses, to remove the breaks that tumors exploit, and to help immune cells recognize threats they once missed. In some cases, immune cells are collected, trained, and returned to the body better prepared for the fight ahead. What amazes me most is that this is not science fiction. It is happening now, in hospitals and research centers around the world. Patients who once had very limited options are experiencing longer survival, sometimes even remission, because their immune systems have been given a second chance to do what they were designed to do. Of course, there are still uncertainties. Cancer remains complex, unpredictable, and deeply personal. But when I step back and look at the bigger picture, one thought keeps returning to me. The same biology that allows cancer to evolve is also the biology that allows humans to learn. And that means this story, the war inside the body, is still being written, and for the first time in history, we may finally be learning how to turn the tide. When I step back and reflect on this journey, one lesson feels impossible to ignore. Our bodies are fighting for us every single day, often without recognition or gratitude. Health is not something we should take for granted. It is something we must protect through awareness, good habits, and respect for science. The more we understand how our bodies work, the better decisions we can make about sleep, nutrition, stress, and medical care. Knowledge is not just information, it is a form of protection. And sometimes, the most powerful step we can take is simply paying attention to what keeps us alive. Now I'm curious about you. What is one small habit you believe helps protect your health every day? Please share your thoughts in the comments so others can learn from your experience. And if you found this story meaningful, consider subscribing to the channel to support us and keep this journey of discovery going together.